Hello, everyone. This is Mr. Thompson, and we are starting electrical induction, and we're designing an electromagnet design lab. So your two choices are you can use nail size, or you can use the number of windings. Now, if you're going to do nail size, I would probably use 50 to 40 windings per nail. The sizes of nail there are 5 different ones. And the 5 different nails are these. So these nails are a 6 penny, an 8 penny, a 10 penny, a 12 penny, and a 16 penny nail. Now these nails are all steel and iron core. If they're not iron core, you cannot make an electromagnet out of it. So the next thing is your coil. Now your coil comes to you like this. Now your coil is wound up with a single turn in it. So you unturn it once. When you return it, you want to do it in the same way. Now this is special wire. This is not your typical wire. This is called enamel wire, and it's for electromagnets, motors, and speakers. So what it is 26 gauge wire that has varnish on it. Now I'll show you what the varnish looks like here. The varnish is reddish, and above it I've scraped the top ends. Now you need to scrape the ends of both ends of this wire. If you do not scrape the ends, this will not work. So now what you're going to do is then wrap and count the number of wraps on your electromagnet. And it's got 20 or 30 windings on it. I'll put a couple more on it just because it's pretty easy to do. Now, so here I am winding up my electromagnet, getting a few more, and I'm going to slide it down. Now, the direction you run your battery through it makes a difference. So I always try and leave at least a couple of inches here at the end to work with. And I'm going to use that on the flat end because it holds easier for my hands. And I shake pretty badly, so this isn't easy for me at all. But you want to learn to see if your magnet's going to work right. Now it's going to get a little bit hot when you do this. And when you do it, your electromagnet should pick up some stuff. Now, when you release the electricity, it'll drop. And what you're supposed to do then is count how many paper clips it picks up. So 2, 4, 6 on that pick. So I'm going to do it again. Same thing on this end of the battery, flat end on the flat end. You want to keep your nail head, your coil next to your nail head. Now here we go again. And I dip it in my paper clips and I pick it up. And here they are. Now I'm going to drop it over here and count again. You got 2, 4, 6, 8 that time. And then you'd record it in your lab. Now your lab should be written up as a procedure now. And I'm going to show you what a procedure would look like. Let's see. I'll go to probably Callie's is pretty decent. Let's go to Callie's or somebody else's. I don't know. We're just going to grab one that looks half reasonable that was working yesterday. Come on, open. Why are you being so slow? There it is. Okay, let's go here. And electromagnet design lab. So we'll go to this one. So basically what you're doing, you researched what's going to happen here. Here's what an electromagnet looks like. That's the one we just built. Independent variable. She's going to use nail sizes. And then she told me why she's going to use them. Down here she has a bunch of things, and we're going to make those all the same size. Let's make 14 point, just make it easier on here. There we go. Now we go down below. So you'd put your runs here, and here she'd put the nail size. The nail I just used was the 16 penny, so you'd put a 16 penny, a 6, an 8. And up here you'd say paper clips lifted by different nail sizes, 60 windings, 40 windings, 30 windings. It looks like it's about 20 or 30 on this one. That's why it didn't pick very many. But that's how you would do your design lab. Now you would collect your data. Now here, sometimes you get a bad lift and something doesn't work. Like the first one lifted 6, the second one lifted 8. Why do you think that happened? That's kind of what you're going to write in here. Just maybe some observations. Maybe the wire got hotter that time. I don't know. Something simple. And then what you're going to do is you're going to graph your data. Up here, she should have made a prediction about what happens when the core gets bigger. Let's see if she actually did that. I am going to change the nail sizes going down and wrapping the wire around the nail. So she needs to talk about what the nail size is going to do. So we'll talk to her on Friday to make sure she makes a prediction in that. And that's pretty much how you go about doing this. Now, when you're done with your wire, what you want to do is unwind it again. So now it's off my nail. And you straighten it out by just running your finger over it or dragging it over one of our school lab tables is really good. Then you use 3 fingers and you wrap it around itself, just like this. Now you have a single wrap of wire with a simple twist. And this will make it ready for you to use the next time you use this. And this is the way it looks when you're done. Now, this is the best way to store this wire. You're going to use this wire next on an electric motor, and then on a steam-powered electric generator, and then on an electric speaker. And then when you're done, you wrap it all back up, you put it back in your box, and you send it back to school. And thank you very much.